Hi, welcome to MooMooMath. Today we're going to look at power reducing formulas. So here are the formulas, the three formulas we're going to work with algebraically. So if you're trying to take a sine squared, so a second degree, and you want to bring it down to a first degree, you're going to use sine squared is equal to 1 minus cosine of 2x. Now notice this is a double angle right here, all over 2. Now you can factor this 2 out, and that would become 1/2 times the quantity 1 minus cosine of 2x. So yes, we're reducing the power to a first degree, but we're also doubling the angle. So cosine squared of x, to reduce it, that's going to be 1 plus cosine of 2x, again a double angle, all over 2. The only difference between these two equations is the sine, S-I-G-N, in front of cosine. So we have a negative in the cosine or the sine formula and a positive in the cosine formula. And again, you can factor out the 1/2. Now for tangent squared x, we're going to rewrite that or use the identity 1 minus cosine of 2x all over 1 plus cosine of 2x. Again, we're reducing the power to a first degree equation, but we are doubling the angle. Now, I wanted to show you the derivation. Where does this tangent equation come from? Well, tangent, we know, is equal to sine over cosine. So tangent squared is equal to sine squared over cosine squared. Now, we can use our power reducers for sine squared and cosine squared using the above equations. So to reduce the sine squared, we're going to use 1 minus cosine of 2x all over 2. And to reduce cosine squared, we're going to use 1 plus cosine of 2x all over 2. Now, we can take these and multiply both the denominator and the numerator by 2 to get rid of our complex fraction, which is in the form of 1 as 2 over 2, and we end up with 1 minus cosine of 2x all over 1 plus cosine of 2x. And that's where that tangent power reducer comes from. It's just from sine over cosine. So we can derive that. Now let's look at a couple other derivations. We're going to derive the cosine squared power reducer identity from a double angle formula. So we know cosine of 2x, the double angle formula, has 3 different forms. The first form is cosine squared minus sine squared. The second form is 2 cosine squared x minus 1. And the third one is 1 minus 2 sine squared x. Now, the one we're going to use to derive the cosine squared is the second one. Okay, we're going to use the second equation. So we're going to take the double angle equation, cosine of 2x equals 2 cosine squared x minus 1. And all we're going to do is isolate the cosine squared. So I'm going to first add 1. So let's take cosine of 2x, and we're going to add 1 to that. And that's going to give us 2 cosine squared x, and then divide by 2. And guess what we have? We have the power reducer. So the power reducer for cosine squared x is equal to, whoops, that should have a 1 right there, is equal to 1 plus cosine 2x, the double angle, all over 2. And that is our power reducing equation that we've just derived. Okay, now let's derive the power reducer for sine squared x by using the same identity, only in the sine squared form. So we're going to use the double angle for cosine, and we're going to use the form 1 minus 2 sine squared to derive it. So let's start first by writing out our cosine of 2x, the double angle, is equal to 1 minus 2 sine squared x. Now we want to isolate sine squared. So what's the first thing we're going to do? We're going to subtract 1 from both sides, and that gives us cosine of 2x minus 1 equals negative 2 sine squared x. Now let's divide everything by negative 2 to isolate sine squared. When we divide by negative 2, let's kind of clean this up. That's going to make this a positive 1 and that a negative 2 cosine, or cosine of 2x. So let's write this as 1 minus cosine of 2x all over positive 2 is equal to sine squared x. And there's our power reducing formula for sine squared. And all we've done is use the double angle for cosine to find that. Now, these are so we've used the double angle for cosine to isolate the power reducer for cosine squared and for sine squared. Now let's use these with some identities to just simplify. Okay, so we're going to start with 8 sine squared of 3x, and we want to power reduce it to a first degree expression. So since we're dealing with sine squared, we're going to use this identity. And of course, let's use the one that's a little more simplified, that's distributed in. We're going to use 1 minus cosine of 2x all over 2. So we've got a coefficient of 8. I'm just going to write that on the outside, and I'm going to use substitution to replace my sine squared. This is going to be 1 minus cosine, and I have to use a double angle. So when you power reduce, you're going to double your angle. So instead of being 3x, this is going to be doubled to 6x all over 2. Now this does simplify because 8 can reduce with 2. So I'm going to have 4 minus 1, or 4 times 1 minus cosine of 6x. And then to simplify that even further, go ahead and distribute this 4 in. So you're going to get 4 minus 4 cosine 6x. And there's our final answer, simplified and distributed. So there's our first example. We took sine squared of 3x, 8 sine squared 3x, and simplified it to a single angle. So cosine in this case is not squared, but we did have to double the angle. Now let's try one with cosine. Okay, so let's try a cosine formula. So we have cosine, 4 cosine to the 4th x. Now we don't have a 4th degree power reducer. So what we've got to do is we've got to separate this into 4 times cosine squared x times cosine squared x. So we're going to have to power reduce twice, one for this cosine and one for that cosine. So let's bring this down, and we're going to have 4 times, well, the power reducer for cosine squared is 1 plus cosine 2x all over 2. So let's write this as 1 plus cosine, and I've got to double the angle. Since it's just x, that's going to be 2x all over 2 times another 1 plus cosine double the angle to 2x all over 2. Now, our denominator is 2 times 2, or just 4. So I can cancel this 4 out with both of these denominators. So now I've just simplified this to 1 plus cosine of 2x times another 1 plus cosine of 2x. Now, as you can see, we have two binomials, and we need to multiply these together. So let's FOIL this out. So first is going to give me 1 plus outer and inner. That's going to give me 2 cosine of 2x. And then my last, when I FOIL the last two together, I'm going to get cosine of 2x times cosine of 2x. That's cosine squared of 2x. Okay, so have I gotten this down to a first degree equation? Well, yes and no. This portion is all first degree, but I have a second degree here. So I then have to replace cosine squared of 2x with a double angle formula yet again. So let's bring down our first two terms, 1 plus 2 cosine plus 2 cosine 2x. And then let's replace this with the double angle formula. Well, for cosine, it's 1 plus cosine, and then I have to double my angle. So that's going to be 4x all over 2. Okay, so I'm basically done other than simplifying this, because I'm now down to all single powers. So I've got 1 plus 2 cosine 2x plus, and let's separate this into two parts, 1/2 plus 1/2 cosine 4x. Okay, so I can now combine my 1 and my 1/2. That becomes 3/2 plus 2 cosine 2x plus 1/2 cosine 4x. And guess what? I'm officially finished. There is the final answer for power reducing 4 cosine to the 4th x. So let's kind of go back and look at this one. It's a little more involved. We're just going to separate, bring this coefficient 4 out, and we're going to rewrite cosine to the 4th as cosine squared, cosine squared. We replace the cosine squares with the power reducer that we have. Then from there, we just simplified the denominator with the coefficient of 4, which made it kind of nice. Then we had to multiply these together, so we FOILed it out, which then created a second degree. We took that second degree, we replaced it with a power reducer with a doubling the angle. Then we simplified that into two parts, 1/2 and then 1/2 times cosine 4x, and we combine the half with the 1 and we're done. So there we go. Okay, so let's try one that involves both a cosine and a sine. Okay, the nice part about multiplying these together when you power reduce, they're both going to be in terms of cosines, so that helps. So let's replace cosine squared with 1 plus cosine. Let's double the angle. Well, the angle's just x, so doubling the angle will just make that 2x all over 2 times the power reducer for sine squared is 1 minus cosine, again doubling the angle, so 2x all over 2. So there's your first step. It's just the substitution. Now we need to multiply these together. So I have a binomial times a binomial. So in the numerator, I'm going to FOIL that together. The denominator is easy. 2 times 2 is just 4. So let's multiply 1 plus cosine of 2x times 1 minus cosine of 2x. And hopefully at this point you're going, okay, I kind of recognize those. Those are conjugates. So I'm going to end up, once I multiply that together, I'm going to get 1 minus, outer and inners cancel, and I get 1 minus cosine squared of 2x all over 4. Now, we need to power reduce yet again, because once we FOIL this out, we now have a second degree. So let's simplify that as 1 minus the quantity. Well, I'm using the power reducer right here to reduce it yet again. And that's going to be 1 plus cosine, and I have to use a double angle. This is starting with a 2x, so that's going to double to a 4x, all over 2, all over 4. Now, we got to do a little cleaning up here. So in the numerator, I'm going to have 1 minus the quantity of 1/2 plus cosine 4x all over 2. So I've just separated that into 2 parts, all over 4. Then from here, I've got to distribute this negative in, and that's going to give me 1 minus 1/2 minus cosine 4x all over 2. And that whole thing is all over 4. Well, 1 minus 1/2, that's just going to be 1/2. Minus cosine of 4x all over 2, all over 4. Now, we could do the keep change flip, so let's multiply by the reciprocal. So we're going to multiply by 1/4, multiply the whole numerator by 1/4 so that we can cancel these out. So that's a keep change flip property, and that's going to give me 1/8 minus cosine 4x all over 8. And there is our final answer to a power reducer. So that's equal to cosine squared x times sine squared x using a power reducing formula. So there we go. Let's try one more, and this time we're going to throw a tangent in there because we haven't done one with tangent yet. So rewrite the expression in terms of the first power of a cosine function. So we know that we can write these in terms of cosines. So let's bring down the 2, and let's replace our sine and our cosine with some of these formulas. So cosine squared, or sine squared of 2x, I'm going to use my power reducer right here. So that's going to be 1 minus cosine, and then I have to double my angle. So we're starting with the 2x, so that's going to be a 4x all over 2. And then I'm going to take my tangent squared and replace it with my power reducer. So that's going to be 1 minus cosine, and I've got to double the angle to 4 cosine all over 1 plus cosine of 4x. Okay, so there's my first step. Now let's cancel out the 2's. That's kind of nice. That 2 is gone. And I end up with 1 minus cosine 4x, quantity squared on top, all over 1 plus cosine of 4x on the bottom. Now, I don't have a first degree on top yet, so I'm going to have to multiply this out. So I have a 1 minus 4 cosine 4x times another 1 minus 4 cosine x. So that's going to give me 1 minus 2 cosine 4x plus when I multiply that together, that's going to give me cosine squared of 4x all over 1 plus cosine of 4x. Now, you can see this is not a first degree power. So I have to take this portion and use my power reducer for cosine. So let's take a look at that. That's going to be 1 plus cosine double the angle all over 2. Well, my angle is 4x. So I'm going to have to double this part to an 8x. So let's go down, use the cosine power reducer. So I'm going to bring down 1 minus 2 cosine 4x. I'm going to replace this cosine squared with the power reducer, 1 plus cosine, double my angle, 8x, all over 2, all over 1 plus cosine 4x. Now we need to do a little more cleaning up because I have some complex fractions in here. So we've got 1 minus 2 cosine 4x that I can just bring down, and I can take this portion and split it into 2 parts. So plus a half plus cosine of 8x all over 2 all over 1 plus cosine 4x. And I have this half thing I need to factor out. So before we factor out, let's combine some things here. I can now combine the 1 and the 1/2 to 3/2 minus 2 cosine 4x all plus cosine 8x all over 2 all over 1 plus cosine 4x. Now my numerator still has fractions in it. So let's go ahead and factor out that half. If I factor out a half in front of my numerator, that leaves me with 3 minus 4 cosine 4x. Now let's stop for a second and look at that 4. If I divide 2 by a half, I get 4, because if you think about it and distribute it back in, that would be true. Half of 4 is 2, okay, plus cosine 8x all over 1 plus cosine 4x. Well, isn't having this 1/2 the same as having it on the bottom? So really, I'm saying 1/2 times this whole quantity, 3 minus 4 cosine 4x plus cosine 8x all over 1 plus cosine of 4x. So really all I need to do at this point is distribute the 2 into the denominator. So I have on top 3 minus 4 cosine 4x plus cosine 8x all over 2 plus 2 cosine 4x. And I no longer have complex fractions. And there is my final answer. Wow, that took a lot. So let's go back and look through the steps. Okay, I just brought the 2 out front, and I replaced the cosine squared of 2x with the double angle power reducer. So I got 1 minus cosine 4x all over 2. I took tangent squared and replaced it with its power reducer, 1 minus cosine of 4x, again doubling the angle, over 1 plus cosine squared, or cosine of 4x. Then I canceled out my 2's, and I had 1 minus cosine 4x, quantity squared on top, all over 1 plus cosine of 4x. Now, this is not a first degree, so I had to multiply it out. So I'm just FOILing or multiplying 1 minus cosine 4x times 1 minus 4 cosine x, and that gives me this trinomial, 1 minus 2 cosine 4x plus cosine squared 4x, all over our denominator. So we ended up with a squared function. We then have to use a power reducer that doubles our angle. So we replaced it. Now we combined our like terms on top. What we had to do was separate this into a half and then cosine 8x all over 2. And we could then combine the 1 and the 1/2, which became 3/2. Then we had to factor out, because we have a complex fraction in the numerator, we factored out a half out of the numerator, which then doubled this to a 4. Okay, once we factored that out, we brought this 1/2 mainly out in front of the whole fraction, and then distributed the 2 into the bottom, and that's how you get rid of your complex fractions, and boom, there we are, we're done. So there's quite a bit to do on this power reducing, but just take one step at a time, apply your algebra correctly, and you'll have it. So there we go. That's the final question on the power reducers. So these are your power reducers that we're going to use, and let's review them very quickly. Sine squared x is equal to 1 minus cosine of 2x, so again doubling the angle to power reduce it, all over 2. You can also factor the 1/2 out and write it as 1/2 times 1 minus cosine of 2x. It's preferable to leave it multiplied in. Cosine squared of x, that's 1 plus cosine of the double angle all over 2. Again, you can factor out the 1/2. And then tangent squared is sine, which is your sine, over your cosine, which is your cosine, with the 2's canceling out, and there's your power reducer for tangent. So the tangent one's kind of easy if you know sine and cosine. Okay, there you go. How about the power reducer practice problems? And thank you for watching.